In this lecture, we are going to cover data types. So in the last lecture, we discussed about variables. Now in C, there is a condition that whenever we want to use a variable, we need to declare it before using that variable. And while declaring the variable, we need to tell that what is the data type of that variable, which means that what kind of data the variable is going to store, whether it is going to be an integer, a decimal value, or a character. So in this lecture, we are going to know what all data types are available and when to use which one of those. So there are four different categories of data types. First one is basic, which we are going to cover in this particular lecture. The basic data types are further of four types: character, integer, float, and double. In just a short while, we will look into the details of each. The other data types are derived, which is further of three types: pointers, functions, and arrays. Then there is user defined data types, which is structure, union, enumeration, and type def. And the last one is void. But we are not going to discuss these three. We are only going to focus on the basic ones in this particular video. The first basic data type is int. Int is for integer. So whenever you want to store an integer number, that is any number without a decimal value, that's an integer number, then we are going to use the data type int, int. Now what is the size of the integer? Which means that what is the biggest number and what is the biggest integer number that you can store in a variable. So typically the size of the integer is dependent on the compiler that you are using and the system architecture. But nowadays on most of the systems, you will see that the size of the integer is 32 bits, which means 4 bytes. So if the size is 32 bits, this means you can store the values from -21474836648 to 21474836647. I will also discuss later in the video how we reach to this particular value. Now you can see that this range is pretty large. Now you can see that this range is very large. The number is very large, 21474836647, right? If you are sure that this number you are not going to reach, your maximum limit or the maximum number for your situation is very less, then you can use short int. Short int uses only 16 bits. Now what does this mean that its size is 32 bits? This means that in the memory for an integer, 32 bits of memory are reserved. Whether you use those 32 bits or not, but that will be reserved. For example, let me give you a very simple example. If let's suppose you are going to declare a variable x whose value you save is 5. Now how we represent 5? 5 is 1, 0, 1, right? 32 bits are reserved. So this means on the left, in total these bits will be what? 32. Okay. So you can see that out of 32 bits that will be there. So I'm not going to write all 32. All zeros will be there. Only first 3 bits are actually used. Okay. 101. Rest all are 0. So when I am pretty sure that I will not require such a big number. So why to waste 32 bits for every variable that you are going to declare? So in that case, you can use short int also, which will reserve 16 bits. So your maximum range should be till 16 bits. We will see what is the range for short int also. The opposite, if you know that your value is going to go beyond 21474836647 or the negative counterpart, then you can use long int. So for long int, the size is often 64 bits in a 64-bit system. Okay. So depending upon what will be the size of the integer that you are going to use, you should use either an int, a short int, or a long int. The next basic data type is character, char. So the size for the character is 8 bits. So character is any digit or any alphabet or any special character. So A is a character, right? Even 1 is a character, or at the rate. So if you put these in single quote, that becomes a character. The size is 8 bits and the range is -128 to 127. Next is floating point data types. So whenever you need to work upon numbers which have decimal values, then you need to use floating point data types. There are 3 floating point data types. The first one is float. The size is 4 bytes and the range is from plus minus 1.18, 10 to the power minus 38 to 3.4 plus minus 3.4 to 10 to the power 38. If the value required is greater than this, beyond this particular range, then you can go for double, whose size is 8 bytes and accordingly the range will change. Still you need a greater size, then you can go for long double. The size is implementation dependent and is typically larger than the double, which means that it will be greater than 8 bytes but will depend upon the implementation, how it is implemented in the system. Now let us understand how this range is calculated based upon the size. For example, I'll take a simple example of character, wherein we saw that the character size is 8 bits and the range was -128 to 127. It's important to understand this because there's another concept of unsigned character or unsigned integers which will make more sense once you understand how from 8 bits or any number of bits, 16 bits, 32 bits, how this range is calculated. Okay. So if the size is 8 bits, this means what? 2 to the power 8 numbers can be stored. And 2 to the power 8 is what? 256. Isn't it? So why the maximum number is 127 or -128? Because out of the 8 bits, so 1, 2, 3, 4, 5, 6, 7, 8, the first one is reserved for the sign plus or minus. So how many are left? 7. 2 to the power 7 is what? 128. That's why this range is from -128 to 127. Okay. Same is true for short int, whose range is what? 16 bits. So the first bit is reserved for the sign and the next 15, from those 15, 2 to the power 15, you can calculate the range. Similarly for integer also. Now there is one more concept of unsigned. So unsigned integer or unsigned character. So we have seen that the range of integer or character is from negative values to positive values. And the first bit was reserved for the sign. So this means I am wasting some space, right? Just for the sign. So if I am sure that the value that I am going to enter as an input is going to be positive only, then I can double the range by neglecting the negative values. Okay, like for example, for character it was -128 to 127. This means there are how many values? 128 positive values and 128 negative values. But if I am sure that there will be only positive values, so I don't need this negative, and all these negatives can be added to positive, thus doubling the range of positive values. So this will go from 0 to 255. And how it is done? By not considering the very first bit for the sign. Okay, so we will be using all the 8 bits for the values, the numbers. Thus the range will increase from 2 to the power 7 to 2 to the power 8. Okay, remember the very first digit will not be used for sign, whether it is negative or a positive number. So your range will increase because all 8 bits will be used. Hence 2 to the power 8, the range will increase to 256. So for signed character, 8 bits, size will remain the same, but the range will double. So for signed it is 128 to 127. For unsigned, size will remain the same, but the range will double from 0 to 255. So you can see there is no negative value here. Same goes for signed integers. Size is 38 2 bits. Range we have already seen. So this is from -2147, right? In unsigned, size will remain the same, but the range will double. So you can see 0 to 4294967 Same goes for unsigned short int. 16 bits is size minus 32768 to 32767. If I use unsigned, then the range will double from 0 to 65535. The last thing is the specifiers. This is very important. Whenever we want to print the value of any variable, we have to tell what kind of a variable it is. And for that, we will use a specifier which is different for every data type. So either you print the value of the variable or you want to take as input the value of the variable from the user. You have to tell the specifier for that particular variable. So this you need to memorize. For integer, the specifier is %t. In the next video, we are going to see all this with an example. Okay, so from here, you just learn these specifiers, and in the next video, we will do the practical implementation and understand how to use these specifiers. Integer, it is %d. For short int, hd, long int, ld. Unsigned, we'll change it to u, unsigned short, hu, unsigned long, lu. For character, it remains same, %c, either it is character or unsigned character. Float is f, double is lf, long double is capital LF. Now at times you might want to represent the decimal number at integer in octal form. Alright, decimal number in octal form. For example, decimal 8 in octal is what? 10, right? Similarly, you might want to represent the number in hexadecimal. So 10 in decimal is A in hexadecimal. So if you want to print the octal values, you need to use %O. If you want to print the hexadecimal values, then you need to use %x. Small x if you want to print small a, b, c. Capital X if you want to print capital A, capital B, and so on. So you will understand all this with the help of the program. Do subscribe so that you do not miss on the next video. Till then, take care.